My name is Cedric, and in this little demo here, we'll be going over how to properly um, set a input and output delay to our clock. All right. And we'll be doing this by going into the timing constraints for our FSM design. We're not too interested in the FSM design for this video. Uh, we are mainly more interested in how the clock is running and how the input and output delay is being um, can be interfered from the clock cycle in that is in our design, right? Um, so here I essentially created a clock, and I named it my only clock. And this clock has a 50% duty cycle with a period of 10 nanoseconds, which comes out to be 100 megahertz. All right, and for this design here, I introduced well, for my constraint file, I introduced an input and an output delay, and these both have a clockage that are both rising. All right. And I'm just throwing out a wild guess right now. I don't know which type of delay time would work the best with our set frequency, our set clock frequency, right? Um, but those are the three things that we've added. So, but again, our main issue is going to be the delay value here that we're going to have to fluctuate. But we're gonna have to see why that value doesn't work out all too well. All right. So looking at the timing summary and by implementing our design, we would see here that we are going to get a WNS value of 8.849, right? And this is just means the WNS and the TNS just mean like by how much it is out of reach from the clock cycle, from my understanding. And we want it to be uh, at a certain point where it is able to be in sync with the clock cycle. All right. And so to configure it so that it is in quote unquote in sync, we have to configure the input and output delays, right? And so this just takes a lot of trial and error from what I've noticed. There's not really a large method to it. Sometimes you'll be hitting like negative 0.05, and then the TNS will also be like negative 0.05, right? And then you'll try to fluctuate the input delay by zero point 0.5 and the output delay by zero point 0.5. And you just do this constantly until you get a positive a value, which would uh, yeah, it would give you just a positive value. So by using an input delay of 2 nanoseconds and a output delay of negative 3 nanoseconds, and by rewriting the implementation, by also rewriting the synthesis, then we would notice that we would get a positive value for our WNS, which is what we want. As we will see here, that we would, oh, let me pull this up. As we would see here, we're not getting any more errors over here. So by us not having any more errors, we would be able to say that we are good here and that the input and output delays are uh, in sync with uh, the clock cycle that we have configured with 100 megahertz. All right. So in this lab, I've definitely learned a lot on how we can manipulate the constraint file because that's important and that's something that I did not know we could do. That we can just configure it by going to the in a sense behind the scenes. Um, where if we went to implementation and we went to edit timing constraints, we were able to actually go behind here and actually look into all the things that we could actually configure as there are plenty of other things that we could actually configure, and I think that's pretty cool. The other thing is that I also learned how much of a headache it was to actually get a positive value for our WNS, because it took me quite some time to actually get a this good value. Um, I, uh, all in all things were a success for our timing.